Happy campers. Today we're going to be looking at absolute value inequalities. So we just did absolute value equations. Today we're just going to do inequalities, and we're going to focus today on the less than ones. So just like before, we're going to have two inequalities to solve. But what you need to remember is if the original problem has a less than symbol, the final answer is going to be one of these compound inequalities that are smushed together, and then our graphs are always going to be shaded between those two values. So our graphs will always look the same on these. You don't have to worry about figuring out if they overlap or whatever. They'll always look the same. Okay, so the first one is very, very simple. The absolute value symbol is isolated. It's set equal to a less than, so we would have the original one. And then remember, we have the negative version. But remember, with inequalities, on the negative one, you got to flip that symbol. So it's going to be that one. And then we're going to take that, and our final answer is going to be in this form. We're going to put the small number on the left, so that would be -3. The bigger number on the right, that would be +3. X in the middle. And these symbols will always be less than symbols. These ones are less than or equal to, though, of course, since our original had the line underneath. So there's our final answer. We put the small on the left, the big one on the right, and the X in the middle. And then we just quickly put it on a number line. We know how all of these will look because I told you already. We'd put -3 on the left, +3 on the right. These would be closed circles, and we would shade in between. All of these graphs that start as less than symbols are going to be shaded in between with the absolute values. So it's going to be nice and easy. You don't have to think about graphing these. Number 2, the absolute value symbol is already isolated, so we're able to write our two separate inequalities. So we would have n minus 6 is less than 2, and then n minus 6 is greater than, don't forget to flip that symbol, -2. So we have the positive version and the negative version. Both of these are solved by adding 6 to both sides, so I'd get m is less than 8 and m is greater than 4. So remember, just because the first one's 8 doesn't mean the other one's -8, so make sure you're doing the math, because you'll see I got 4. So I know I can put this as a final inequality. 4 would be on the left because it's smaller, m in the middle, and then 8 on the right because it's the bigger number. And then I always am using less than symbols. These ones don't have the line underneath because my original problem didn't have the line underneath. And then I can just quickly put this on a graph. I know that 4 is on the left and 8 is on the right. Both would be open circles. And I would just always shade in between on those less than original problems. Number 3, b plus 1 is less than 3. B plus 1 is greater than -3. Subtract 1. B is less than 2. Subtract 1. B is greater than -4. So -4 is smaller, 2 is bigger, B in the middle, less than symbols. For the number line, -4 on the left, 2 on the right, open circles on this problem, shade in between. Okay, on number 4, we want to look at it, and anytime you have a negative over here, you want to stop and think. Okay, think about what it means to be an absolute value. So anytime you've got that negative and you're dealing with absolute value, remember that always produces some kind of special situation. So I have to think, can I take the absolute value of something and it be less than -13? Well, what does it mean, absolute value? Remember, absolute value is always positive because it's the distance away from 0. So can the distance away from 0 be less than a negative number? No, so this is no solution. So it's similar to the equation. So if you have a less than symbol and it's negative number, it's going to be no solution. We'll see tomorrow. We'll be dealing with greater thans, and we'll think about that situation then. Okay, and then I just put the hint on here. Remember, make sure the absolute value symbol is isolated before you write your two inequalities, or else you won't get it right. So this one we have to isolate by subtracting 1 from both sides. And then I would have the absolute value of 5x plus 1 is less than or equal to 9. Now that my absolute value symbol is on its own side of the inequality, I'm able to write my two inequalities. First one, 5x plus 1 is less than 9, and 5x plus 1 is greater than or equal to negative 9. So I would subtract 1 from both sides. 5x is less than or equal to 8. Divide by 5, and we'll just leave it as the fraction. It doesn't reduce. We get 8/5. On the second one, we would subtract 1. 5x is greater than or equal to negative 10. Divide by 5, and you've got negative 2. Okay, so again, my original problem started as that less than, so it's going to be the smaller number on the left. Negative 2 is always going to be smaller than any positive number. And these were lines underneath, so they'd be less than or equal to symbols. Just put them real quick on a number line. It's already in the order you need it to be in. This time it's closed circles and shade in between. On number 6, it's a great time to pause the video and try that, and then we can compare answers and see how we did. Okay, let's see how you did. The first thing you need to do is isolate the absolute value. So we would subtract 5 from both sides. The absolute value of 3x minus 2 is less than or equal to 4. Now we can write our two inequalities. The first one matches the first without the inequalities. The second one, we have to flip the inequality and change the sign to negative. So we would add 2 and get 3x is less than or equal to 6. Divide by 3 and you get 2. On the second one, we would add 2 and 3x is greater than or equal to negative 4 plus 2 is negative 2. Divide by 3 and it doesn't go into it evenly, so we'll leave it as the fraction negative 2/3. So I put the smaller number on the left. A negative number is always smaller than a positive number, so the negative number is always going to be on the left. And then this time again I had less than or equal to symbols. So I've got my final inequality and then my final graph, negative 2/3 on the left, 2 on the right, closed circles once again, shade in between. And there's no backside today, so there's a special gift for you on a special Monday. Let me know if you have any questions on this. I'll be happy to help you out. Good luck, and we'll see you tomorrow. Have a great day, guys.